This is lesson 3-7a. We're going to be simplifying algebraic expressions by combining like terms. So I want you to write combining like terms on your page, and let's think what this word like means. If we're talking about terms that are alike, terms that are alike are similar. So we are going to be looking for terms or variables that are similar. Okay, remember that terms are separated by addition and subtraction signs. So we'll be looking for terms between addition and subtraction signs with the same variables. Let's look at the textbook definition for like terms. It says terms that have the same variable part, so that's the same letter, such as y and 2y are like terms. So let's add this vocabulary like terms to our notebook. So in your notebook, let's write like terms have the same variable, which is the same letter, and the same exponent. So they have the same variable and exponent. Because what I mean by that is we could have an example that says y plus 2y plus y to the third power. Well, y by itself is really y to the first power. 2y is really 2y to the first power. And y to the third power has an exponent of 3. So the only like terms here are y and 2y. We can combine those. Y to the third power does not have the same variable part because the variable is to the power of 3. So to simplify algebraic expressions, we're going to use properties of operations to write equivalent expressions that have no like terms and parentheses. So if there are parentheses in the expression, we'll be distributing to get rid of them, and then we'll be combining like terms so that we would only have the term or the exponent or the variable written once. So here we would combine this y to the first power and 2y to the first power. Well, 1y plus 2y is 3y. So I combine those terms, and then I would just bring down the plus y to the third power. So right there, we combine like terms, and we rewrote that expression in simplest form. So the answer would be 3y plus y to the third power. And then look at this little blue box here. It says you can use the identity property of multiplication to write x as 1x. We've been doing that in the classroom. We're used to that. Okay, so let's look at another example. In your notebook, I want you to write, this is number 1, x plus x plus x. Okay, so first let's solve this, explaining all the math that we are doing. X plus x plus x. Well, when we see a variable by itself, what is the coefficient? What is the number that is in front of that variable? The number is 1. So I really have 1x plus 1x plus 1x. So are these like terms? Yes, they are, because they have the same variable with the same exponent, x to the first power. So let's pull that x out of this expression by using the distributive property. So if we're pulling the x out of the expression, we are going to write what remains inside those parentheses. So I use this x, what remains? 1. Plus, I pulled this x out, what remains? 1. Plus, I pulled this x out, what remains? 1. So now let's evaluate what's in these parentheses. 1 plus 1 plus 1 is 3. Parentheses x. Okay, so let's finish this up. Bring down the x. I can cross off this 1 plus 1 plus 1 was 3. X times 3 equals 3x. So if we combine the like terms, x plus x plus x, the answer is 3x. And that makes sense because if we look up here, I have 3 x's. So I have 3x. We are never going to ask you to see all this math. It just explains to us why the math works. So if we say what's x plus x plus x, we just want you to know 3x. Let's try another example. This will be the last question that we show doing all the math and the reasoning for why this works. So 2y minus y. That's really like we're saying 2y minus 1y. So let's factor the y out of this expression. I'm pulling the y out. So if I pull the y out, I'm left with 2 minus, okay, I got rid of that y, 1. Let's solve what's in the parentheses. 2 minus 1 is y. 2 minus 1 is 1. Bring down the y. So 1, y times 1 is y. And that makes sense because if we look at our expression here, 2y minus y. Well, let's subtract the coefficients. 2 minus 1 is 1. Keep the variable the same, y. Okay, so now let's look at number 8 here. Number 8, we have 7y minus 4.5 minus 6y. 7y minus 4.5 minus 6y. So which terms are like terms here? Which terms have the same variable with the same exponent? We have 7y and 6y. So let's rewrite those next to each other. 7y, okay, I wrote that, cross it off. We're going to bring down the minus 6y, bring it down, cross it off. Next, bring down 4.5. So I'm using the commutative property of addition or subtraction, or really it's the commutative property of addition. So let's start by writing number 8 in your notebook. 7y minus 4.5 minus 6y. And let's look for the like terms. I want you to underline the like terms here. So we have 7y minus 4.5 minus 6y. Underline the terms with the same variable and the same exponent. So we have 7y minus 6y. So we're going to combine those like terms. 7y minus 6y, well, subtract the coefficients, 7 minus 6. We're subtracting because of how there's this subtraction sign next to the 6. So 7 minus 6 is 1. Y. Cross those off. We use them. Bring down the rest. Minus 4.5. But we're not going to leave our answer like that. We would just write y minus 4.5. We know that 1y is really just y. So we combine the like terms. 4.5 doesn't have a y, so we cannot combine it. Okay, the last question we're going to look at is number 10. 3 plus 3y minus 1 plus y. Okay, so first let's circle let's circle if there are any like terms to go with this 3. So is there a like term that matches the 3? If so, what is it? It would be 3 minus 1. So what's 3 minus 1? 3 minus 1 is 2. We use them. Cross them off. Let's look at what's left. What's left? I have a 3y. Well, 3y, does that have a like term? Yes, it does. Y. Well, 3y plus y is the same thing as plus 4y. So our answer here is 2 plus 4y. Our answer could also be 4y plus 2. The commutative property of addition allows us to change the order.